before going to start the next part of this topic, I want to see some more problems which you cannot see in the text. Problem number 3. So far I completed 2 problems out of the textbook for sake of CET and competitive exams. So I want to see 3 more problems of this kind. Let us see this. On a circle of radius 2 centimeter, find the length of the arc subtending an angle of 15 degree. See the question, of course simple. On a circle of radius 2 centimeter, find the length of arc subtending an angle 15 degree. Question is, find the length of the arc. L is to be calculated. Circle of radius is 2 centimeter and angle is 15 degree. That should be converted into radians. So you know 180 degree equal to 5, that is you have to say pi by 180. So pi by 180 radians this is. So what happens? 180 degree equal to 5 radians. So 1 radian equal to pi by 180 radians. So that you have to simplify this. And 5 3s are 15, 5 3s are 15, 5 6s are 3 1s are 3 1s are 3 2s are 5 by 12. So how much you have got? 5 by 12 radian you have got. So now what is the formula we have? L is equal to r theta. Question is to calculate, find the length of an arc. The question is here L. So L equal to r theta. R means 2, theta means 5 by 12. So L equal to 2, 22 by 7 into 1 upon 12. So here 2 1s are 2 6s are 2 3s are 2 11s are. So L is equal to you see that 11 by 21. So here you have to see that answer 11 by 21, and you go for writing in terms of centimeters, or you can keep it as it is. If you go for the result pi by 6 centimeters, or you can write it so centimeters, you can say this. So this is the way. Even if you write pi by 6 centimeter also you can write, understand. Anyhow you can write in particularly decimals or in rational number. So this is problem number 3. So now the question is, I told one more question here. Number 4, I want to see the length of an arc. The length of an arc of a circle of radius how much? 25 centimeter. Find the angle subtended by the arc at the center of the circle. Look this, how this can be done. The length of an arc of a circle of radius 27. Find the angle subtended. Very simple. You can see that L is given, R is given. So calculating theta. The question is here, Find the length of an arc. No. Find the angle subtended. But they're not asked whether we have to write in degree measure or in radian measure. But answer you will find in a radian measure only, because when the formula is used. And here, what is length of an arc of radius? R is equal to 25 centimeter. Find the angle by an arc at the center. What do you say? Find the angle at the center of a circle. So what is one more thing is there? The length of an arc. The length of an arc of a circle radius 20 centimeter. Find the angle subtended by the arc at the center of the circle. So here that information, only one info, 25 is here, but the length of an arc, that is not given or not, that we have to verify. The length of an arc of a circle radius 25 centimeter. So problem is incomplete. The length of an arc of a circle 25 centimeters is 32 centimeter. Is 32 centimeters. See, this is incomplete. Once again, the length of an arc of a circle of a radius 20 centimeters is 30, means length of an arc is 32. Now, formula is that L is equal to R theta. The question is theta is equal to L by R. Theta equal to L means 32 by 25. So here you see the answer 32 by 25. What is this? This is radians. So this is the way, because not asked in degree, you can write the answer like this. And now I want to see that other problems, very simple but tricky questions you will see in CET. That's why I am writing these questions for you. Now the next problem I want to see that, see how this is there, somewhat clumsy, that you can observe. So what is that? A wire, look this, a wire of length, try to understand, 10 centimeter is bent so as to form an arc of a circle of radius 4 centimeter. What is the angle at the center in circular measure? In circular measure means what? It is nothing but radian measure. So don't get confusion, very simple is there. And what is question? Indirectly it is given. So you try to understand that a wire of length 10 centimeter is bent so as to form an arc of, suppose you see, ten centimeter arc length, this is 10 centimeter, and here arc length. A wire of length 10 centimeter is bent so as to form an arc of a circle of radius. Radius is 4 centimeter. And what is the angle at the center? What is the angle at the center? So this is. So try to understand here. L is equal to 10, R is equal to 4, theta is question mark. Now theta is equal to L by R. So theta L means 10 by 4. 2 5s are 2 2s are. This is radian. 5 by 2 radian you can say. And this is the way how we can see the answer. One more tricky question is there similar to this that I am explaining here. Number 6, you see. What is the problem number 6? So in 6th you see that a circular wire of radius 6 centimeter is cut and bent so as to form an arc of a circle of radius 48 centimeter. Find the angle in degree. See the question. Find the angle in degree subtended by the arc at the center. See, it is somewhat different. You see how this can be done. The question is information. What is the information? See this first. A circular wire of radius. This is a circular wire of radius 6 centimeter is cut and bent so as to form. So this is required circle in which so as to bend so as to form an arc of a circle. So what is this wire is cut and stretched, and you see what is the length of circumference of circle? Formula is 2 pi r. What is r? 2 pi r into 6, that is 12 pi. Length of an arc is how much? 12 pi. So what I suggest that first you have to understand the circumference of the circle whose radius is 6 and that is 12 pi. So here when look this r is how much it is? When r is equal to 6 centimeter, this implies the circumference of a circle is equal to 2 pi r, that is 2 pi 6, that is 12 pi centimeter. So that is cut into form arc length of a circle. So this arc is 12 pi centimeter, and whose radius is of a circle of radius is 48. The question is, what is this? Now we have to use the same formula and accordingly you can write it. What is that? See this. And what is the formula here? L is equal to, we have theta equal to L by R. Theta equal to L means 12 pi divided by R means 48. So you have to see 12 ones are 12 threes are 4s are 4s are. So theta equal to 5 by 4 radians. Circularly, of course in degrees it comes 45 degrees. So this is the way how you can understand the problems here. Now this is the end of that angle and systems to measure the angles in which sexagesimal degree measure, circular system, radian measure, and also we have studied some properties, and also the conversion degree to radian and radian to degree, and we have completed some essay type problems on this, and this is more than enough to see the questions on this part. That very important part is trigonometry, is trigonometric functions. Now I have to discuss trigonometric functions that already I have done in the high school standard, I mean in the 10th standard. Now I have to explain that how trigonometric functions are defined. I don't want to tell that elementary explanation that you have studied sin x, cos x, tan x, or cosec x, cot x. All 6 trigonometric functions that you know how to define, what is the formula, what is the identities, that part I am not going to touch. Only I have to tell that in different style, different fashion. I have to prove those identities once again simple way in another style, trigonometric ratios, that you can understand it is nothing but trigonometric functions. So trigonometric ratios and trigonometric function, it makes no difference here, and you have to go for to define trigonometric functions, and usually when we are using the angle in terms of radians, always we go for trigonometric functions. Now I have to introduce the trigonometric function in a definite order, definite manner, that you have to remember. Consider one circle, unit circle I am talking. Look here, because very important part. Unit circle, I want to draw this. Unit circle whose center is, unit circle means what? Whose radius is unit. So I want to tell this is the center I want to take, and center is O, and here I have to draw the x-axis and y-axis. Look this is y dash, and this is y. You see that this is x dash, and you know this is x. Consider a circle of unit radius at the center of the origin. So radius is 1 unit, and all this radius, you say O, A, B, C, D, you can tell. But here I want to explain that how to introduce the all 6 trigonometric functions in the other way. Now what I have done, what I have told you here, I have considered that a unit circle is nothing but whose radius is unit, 1 unit, that is called a unit circle. Now I have to explain the 6 trigonometric functions. For that I have to take one point on the circumference of a circle, that to P, whose coordinate is AB, I have to tell. See this, AB, and try to understand AB. So here you have to see this angle I have to take, x I want to take, x radians you can tell, and there is no problem to understand this. When you take this P and it is a perpendicular, you try to understand PM. In analytical geometry, when a point is here and this is called y coordinate and this is called x coordinate. So this y coordinate is B, x coordinate is A. Try to understand. It all depends on the coordinates. So OM is A and PM is B. This is the knowledge we consider in analytical geometry. So you have to tell that angle XOP. Look here, consider a unit circle and at the origin, and take a point P on the circumference of a circle whose coordinates AB, draw PM perpendicular to axis, and also you consider that angle POX is equal to X radian. I have to consider. This is X radians I have to tell. Now I am defining that all 6 trigonometric functions here. So how we define the trigonometric functions or trigonometric ratios? So once again, this is the new methodology that we are explaining the 6 trigonometric functions. So you know that with these alpha letters, so here I have to go for, we define, look this very important point, we define 6 trigonometric functions. Trigonometric functions, or let us say in the beginning, trigonometric ratios. So how to define these I am explaining, and accordingly you can tell that. So here you have to tell that sin x here, see the figure, and from figure only you have to tell b is equal to sin x and a is equal to cos x. Try to understand, very simple. You have to go for a is cos x, b is sin x. Try to understand, this is always cos x minus sin x. This is the way. So now you have to understand that tan x means, this implies tan x is nothing but sin x by cos x. You know this, and that is nothing but sin x is what? B by a. So tan x is what? B by a. That is nothing but, you know, opposite side divided by opposite. So that you know, this is opposite side, this is hypotenuse, and this is adjacent side. So here we understand tan x is equal to b by a. And here you know what is other function, sec x. Sec x is what? It is the reciprocal of cos x. And what is cos x? Cos x is nothing but a. So this implies sec x is equal to 1 upon a. And cosec x is equal to what? That is 1 upon sin x. And sin x is what? B. So cosec x is equal to 1 upon b. See here, how we are defining in terms of a and b, that part I am explaining here. And similarly, when you go for this, and we try to understand one more function, we have left it. What is that? Now, cot x is equal to cos x by sin x. And cos x is what? Cos x is you see, cos x is a, sin x is b. So, a by b. These definitions we are taking just accordingly the first PUC referring from the SSLC standard. There we have defined opposite side, adjacent side, and hypotenuse. But here I have not defined, I have not used. But it is one and the same. Only strictly considering sin and cos, B, A, and based on that we have defined all these things. Now, coming to the point, sir, I hope we define 6 trigonometric ratios from figure like this. Oh, I hope you have understood how we have defined. Now, coming to the next point. So, what next point? Trigonometric identity. Some identities you have proved in SSLC, and the same identities I want to prove here also. Now, so in right angled triangle, what? OPM. See here, in a right angle triangle, OPM. And what is our Pythagoras theorem? This is nothing but what? This is, here I have told you, this is A, OM is A, and this is, here is there A is there. This square plus this square equal to this square. And here it is, radius is 1. because unit radius, so it is radius is 1. Pythagoras theorem, what happens now? A square plus b square is equal to 1 square. So what you say? A square plus b square is equal to 1. So now you have to understand that how you have got a square plus b square equal to 1. That is according to the Pythagoras theorem. Now here you see what is this is Pythagoras theorem, square of a square plus b square equal to 1. And what is a? A is already we have told that cos square x. A means cos square x, b means sin square x equal to 1. Therefore, sin square x plus cos square x is equal to 1. Then you have to understand this. One identity, you got it. So two more identities are there, that I am explaining. This is first identity, and now dividing by cos square x. What we get? Sin square x by cos square x plus 1 equal to 1 divided by cos square x. And here you have to see this becomes sin square by cos square is nothing but tan square x plus 1 by cos square means secant square x. So third identity is that secant square x is equal to 1 plus tan square x. So this is the second and this is the first. And once again I have to go for that dividing equation 1 by sin square x. So what happens? Sin square x by sin square x plus 1 equal to 1 by sin square x. Sin square by cos square means here you have to understand that sin square x by sin square x is 1. This is 1. And here you have to understand that cos square x by sin square x. So this becomes cot square x is equal to cosec square x. So this represents cosec square x is equal to 1 plus cot square x. This is the third one. So you try to understand cos square x plus sin square is equal to 1, secant square equal to 1 plus tan square x, cosec square is equal to 1 plus cot square x. So these are the identities in trigonometry that already you have studied in 10th standard. But here I have not used anywhere else opposite side, adjacent side, hypotenuse. Without using that, I have explained these identities. Now I am going to explain that basically here to understand about the quadrant angles. Quadrant angles means what? That you have to see multiples of 90, 0, pi by 2, pi, 2 pi by 3 and 2 pi, multiples of 90 degree. That is quadrant angles what? Multiples of 90 degree. So that part I have to explain here in this figure. So now we go for suppose if that P lies on the x-axis. I want to see this quadrant angles. Look at very carefully. This is very important for us, and that is easy and most useful results if you find. That is why you try to understand what I am telling here. If P, so 1, 2, 3, 4, again 5. 5 times I am writing the position of the P. Suppose first you see, if P lies on x-axis, that is at A, what are the coordinates of A? You know, this coordinate is x-axis is 1, y-axis is 0. And here B, what are the coordinates? This is x-axis is 0, y is 1. And particularly here you see this minus 1, 0. And here you see that 0, minus 1. Are they coordinates. Now, based on that, P lies on the, see this first point I am writing. P lies on the x-axis, that is at A, you will get 1, 0. X coordinate is 1, 0. And now, what is the value of A? What is, see, at A, 1, 0, what is the angle that you have to see? X is equal to X, that angle X is equal to how many? This, that is X is equal, you see this implies X is equal to 0 degree. That angle is there, you know, what angle, particularly POX, POA, angle POA, that is X, and that is 0 degree. POA, see, when P here, POA, that is X becomes 0. X becomes 0. 2 points I am giving here. X radian is equal to 0 here. X 0, X radian equal to 0. And try to understand that when you write this X is equal to 0, then what comes? And here you see this is A and this is B. When the point is here, try to understand what is, see, A means what? A means what? Here, first is A. A means what? That is cos, and there I told X, and here cos X, and B is equal to sin X. And implies A means what? 1 is equal to cos 0, and B equal to 0 is equal to sin 0. So this implies what? Cos 0 is 1 and sin 0 is equal to 0. See how you have got cos 0 is equal to 1 and sin 0 is equal to 1, that you have understood here. Once again I explain that when the point A, P is at A, P lies on axis, that too at A, 1, 0, and accordingly you can see the results here. So once again I understand that how we change the values like this, and similarly you can go for writing the values here, and accordingly you can find the result. What? Suppose second one I say, if P lies at B, then see that at B, that what are the coordinates of B now here? 0, 1. What is angle here? You see that angle you have to take it here. You have to go for here POA. POA you have written, or POX you write here. That is this angle. POA. A means again it is confusing, POX. That here X is how much? X is 90 degree, pi by 2. X is 90. Or you can say radian 90, pi by 2, whatever else you can say this. And when P lies B, then X is equal to pi by 2. Then X is equal to P pi by 2. Now, you see this. This is A, this is B. And now, see that A is equal to, that is cos, what do you say, cos X, and B is equal to sin X. A means how much? 0 is equal to cos pi by 2, and B means 1 is equal to sin pi by 2. So what is the result is that sin pi by 2 is equal to 1 and cos pi by 2 is equal to 0. This is the way how we find the results sin 90 and cos 90. So similarly you go for other angles, that too. Third one, what? If P lies at B or C, you can say C. What are the coordinates? C minus 1, 0. What is the X? X is equal to pi 180 degree. Now you can see what is A is equal to cos x and B is equal to sin x. A means how much? A means minus 1 is equal to cos pi and B 0 is equal to sin pi. So what is the answer totally? Sin pi is, what do you say? Cos pi is equal to minus 1 and sin pi is equal to 0. This is how we have explained, and accordingly we can go for it. Now I have to see that next part. If P lies, see, second is at A, third is at C. Now I want to explain at D. So what is the result? You can see this. What? 1, 2, 3, 4. What? If P lies at D, what are the coordinates? 0, minus 1. And what is the angle? And x is, then x is equal to angle. X is equal to 2 here 2 pi plus pi, and see up to here 2 pi plus pi by 2, pi plus pi by 2. So and here you can understand what is the angle. So here pi by 2, that LCM is 1, 2 pi, 3 pi by 2. So answer is 270 degree. You have to see that 3 pi by 2. Now accordingly you have to see the result, how we write it now. And now you see what is, where it is, A, B. What is A? A is equal to cos x and B is equal to sin x. A means 0 is equal to cos 3 pi by 2 and B means minus 1 is equal to sin 3 pi by 2. So therefore cos 3 pi by 2 is equal to 0 and sin 3 pi by 2 is equal to minus 1. So here it is the case. And once again, if you go for 90, 180, 270, again you will come back to this point. And again you see this. What is the x here? 2 pi. So that part I am explaining here. Finally, number 5. So it comes back to the same point. So when it starts here, coming to again, you have to see this point. And there also you see P lies again at A, you can write. So once again you see that, same point A, and accordingly you can write the result here. So if P lies at A, once again number 5, if P lies at again P lies again at A. So what is the coordinate values? 1, 0. And what is x? X is 2 pi. Taking one round, 2 pi. So what comes here? A, B. So now what comes? A is equal to cos x and B is equal to sin x. A means 1 is equal to cos 2 pi and 0 is equal to sin 2 pi. So answer is cos 2 pi is equal to 1 and sin 2 pi is equal to 0. This is the rule, and accordingly you can find the results for this. So now you have to go for that you are observing in all cases, and when sin is 0 and cos is 0. When sin is 0, you see this all sin, where sin is 0, here sin is not 0, here sin is pi, and here sin is 0, where it is? Sin is 0, 3. Sin is 0 is how much you have to see. That accordingly you can see the result. So now I tell you, when sin is 0, when cos is 0. You can verify this. About the 0 only I am discussing. Here we have discussed all quadrant angles, that is true, but now you can say in particularly that 2 points you remember. In general, see here, in general you take it sin x is equal to 0 when x is equal to what? Whatever the things you have to take when sin x is equal to 0, that you have to understand, and x is equal to n pi. What do you say? N pi. N belongs to z. Whatever you take, that one sin pi is 0, and you see that n is any 2 pi, 3 pi, 4 pi, 6 pi, however you write it, it is 0. And so try to understand sin x is equal to 0, x must be n pi. Similarly, cos x is equal to 0. In general, I am taking this odd number, that should be taken here, and odd multiple 2n plus 1. 2n plus 1. You take it, it must be odd, whichever you take, 0, 1, 2, 1, 3, 2, 5. So odd multiple of pi by 2. So x is equal to 2n plus, and it is sin is 0, even multiple, not even multiple of integers of pi. Here odd multiple integer of pi by 2. So these two factors you have to remember. Now with this I want to conclude that trigonometric functions in terms of sine and cosine only you have to understand. Once again I repeat, this sin x is 0, x is equal to n pi, n belongs to z, integer. Cos x is equal to 0, odd multiple of pi by 2. So how you say that? We have seen 90, how we'll get it 0. So now coming to the point finally, that you say that all trigonometric functions, of which 4 are expressed only in terms of sine and cos. You take it to tan, you take it to cot, you take it sec or cosec. How trigonometric functions in terms of sine and cosine, that I want to tell you now. First cosec and sec, and then cot and tan, that I am explaining here. So you tell me first how you express that cosec x. Cosec x is nothing but 1 upon sin x. That here x should not be n pi, n belongs to z. Why not n pi? If x is equal to n pi and sin x is equal to 0, when sin x is equal to 0, the denominator is 0. When the denominator is 0, it is not defined. When cosec x is defined 1 upon sin x, so x should not be equal to n pi. Similarly, if I go for sec x is equal to 1 upon cos x, then a cos should not be odd multiple of pi by 2. So this already we have discussed, and this is not equal to 2n plus 1. If it is there, then cos x is 0 and 1 upon cos 0 is not defined. And similarly, you go for tan x. So trigonometric functions expressed only in terms of sine and cos. Sin x by cos x. You see, sin x by cos x. And here also x should not be n plus 1 divided by pi by 2. Why here it is? Because denominator cos x, it should not be 0 means it should not be equal. And similarly, that last one is cot x is equal to cos x by sin x. So here also you see x is sin should not be 0 means what? X is not equal to n pi, that n belongs to z. So this is the way how we have expressed the trigonometric functions in terms of other functions. So this is the way how we understand all 6 trigonometric functions, and out of which 4 are to be expressed in terms of sine and cosine only. Now I want to repeat one more part, that is well-known angles or standard angles. So that part I am explaining here, but basically you have to follow that well-known angles. Some authors use standard angles, and that part you have discussed in high school standards. I am not going to derive those results, only I am taking that results, so that trigonometric ratios of standard angles. So which are the standard angles? 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. These are the standard angles. Now I want to explain, that is sine, cos, tan. So I have to give the results of this, and here you have to understand trigonometric ratios, and 0, 30, 45 and 60, and finally you have to see that 90. Now, how to fill up this box, that I am explaining here. So sine 0 is 0, sine 30 is 1 upon 2, this is 1 upon root 2, sine 60 is root 3 by 2, sine 90 is 1. Once you write like this, you have to write in the reverse order. 1 root 3 by 2, 1 upon root 2, 1 upon 2, 0. Once you write sine cos tan, means sine by cos. 0 by 1 is 0, 1 upon 2 divided by root 3 upon 2. That is 1 upon root 3, 1 upon 2 divided by 1 upon 2 is 1, root 3 upon this is root 3, and 1 by 0 means infinity. That means not defined. That 1 upon 0 is what? Not defined. And that part we are discussing here, not defined. So when you see that not defined, and accordingly you can go for the results. But one thing is there, when results you are taking in terms of radians, this is pi by 6, and this is pi by 4, and this is pi by 3, and this is pi by 2. Even you remember, already I have discussed that pi by 2, next pi, next 3 pi by 2, next 2 pi. So you continue these angles. It helps a lot for you. And remember, how to remember this? Look this when you are going to draw this is A 1 0, B, and here 0 1, and C minus 1 0, D, and you have to see 0 minus 1. First sign, second chord. See, when we are to 90 is over, this is what. Now I am going to take this and this and this at C pi, and try to understand here. First one is cosine and sine is 0, and you try to understand 3 by 2 minus 1, and there you have to see that 2 pi is 0. 0 minus 1 0, and here you understand that when you take for cos, first one you have to take pi. First one is what? Minus 1, and first one is what? 0. First one is what? So minus 1 0 1. So now you go for writing result, that sine by cos tan, and here you see 0 by minus 1 is 0, and minus 1 by 0, and here actually like this when you see not defined, and you here also you can see that minus 1 is not defined, and 0 by 1 is nothing but 0. So this table you have to remember always, and accordingly you can complete the work. So in the next class, I continue with signs of trigonometric functions and allied angles. That completes the first part of the trigonometry. Thank you.